Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 12.2, Simplifying Rational Expressions, Day 1. The first thing that we want to do here is do a little review on factoring. The first rule of factoring is what we need to use for problem number 1. Well, the first rule of factoring is greatest common factor. So what are the factors of 6 that are also a factor of 12? What I really want to do is break down 12 first. Well, I can break that into 2 times 6. This will tell me what I want to break 6 into. That would be 6 times 1. They both have a 6, which means I can pull the 6 out of my original problem. Okay. Then I'll make a set of parentheses. I'm going to take 6x and divide by 6, which will just get me x. Then I'll take the positive 12 divided by 6, get me positive 2, and I would be done. Same thing for problem number 2. Problem number 2, I need to find the GCF between 3x and 9. Well, 3 and 9 are both divisible by 3. 3x divided by 3 is just x. Negative 9 divided by 3 is negative 3. On to problem 3. We have been talking about how to factor these recently. This is one of those situations when I have 3 terms that I want to make a factor tree. So 1 times 6, 2 times 3. The middle term is negative, meaning my larger numbers will be negative. They need to multiply to a positive, means my smaller numbers will also be negative. So which group, negative 1 and negative 6, or negative 2 and negative 3, will add to the negative 7x? It would be the negative 1 and negative 6. So I'm going to break this into x minus 1, x minus 6. On to example 4. Just like in examples 1 and 2, I only have 2 terms here. There's only 2 different ways that you can factor if you only have 2 terms. One is the greatest common factor, like I did in problems 1 and 2, or examples 1 and 2. In example 4, the other way I can do this is the difference of 2 squares. How do I work with the difference of 2 squares? Well, I need to see, is x squared a perfect square? In this case it is. Is 64 a perfect square? In this case it is. Is there subtraction between? Yes, there is. So if that's the case, I'm going to make 2 sets of parentheses. I'm going to take the square root of x squared and put it here and here. So that would just be x. Then I would take the square root of 64 and plug it in there and there. The square root of 64 is 8. Well, how do I get 2 8s to multiply to a negative 64? One would have to be positive, one would have to be negative. That is our factoring review. If you still are struggling with factoring, you really need to come in and see me during a tutoring session, or set up a time to come see me before school or after school. Okay, let's go on to our lesson for today. Today we are going to simplify rational expressions. Basically just means we're going to simplify fractions. Okay, we already know that to simplify a fraction I have to have the same thing in the numerator as is in the denominator. When I have that, I can go ahead and cross them out. So in problem 1, what I'm looking to do is change my numerator to x plus 2. What I want you to really understand is if I have addition between variables and numbers, they are stuck together. I cannot split them up. What I can do in the numerator is use the GCF, or the greatest common factor. So how can I turn 6x into x and 12 into 2? Well, I could do that by pulling out a 6. If I pull out a 6, 6x divided by 6 is x, 12 divided by 6 is positive 2. All that will be over the x plus 2 that's in the denominator. There's nothing I can do with that x plus 2 in the denominator to simplify it. At this point, do I have the same thing in the numerator as I do in the denominator? I do. It will be this x plus 2. So I'm just left with 6 as my answer. Now, the most important part to, or a very important part to remember in when I'm left with just this 6, is that is technically 6 over 1. If you were left with 6 in the denominator, you would have to make that 1 over 6. I couldn't just write the number 6, okay? On to problem 2. What I want to do is I'm looking at the numerator. It is a monomial. At this point, if it's a monomial, I'm going to leave it alone. 12x squared over. Now I'm looking at my denominator. I have 3x plus 6. It is only 2 terms. If it's only 2 terms, I'm looking to do one of 2 things. I'm either going to take out a GCF, or it's the difference of two squares. In this case, I know for a fact it is not the difference of two squares because it is addition. So I'm going to look for a GCF. What number or letter or combination of numbers and letters do 3x and 6 share? Well, 3x and 6 are both divisible by 3. So if I take out a 3, I'm left with 3x divided by 3 is just x. 6 divided by 3 is 2. At this point, what I want to do is I want to look at my numerator and look at my denominator and see is there anything that can cancel or simplify. Well, 12 and 3 are both divisible by 3, meaning my 12 would turn into a 4 and my 3 would just go away. So I'm left with 4x squared over x plus 2. At this point, you may be thinking to yourself, well, I should be able to cancel those x's out. But remember what I said on the first example. If there is addition or subtraction, that x is stuck with the 2. The only way to cancel that x is if you cancel the whole expression x plus 2. And I would need an entire expression x plus 2 in the numerator to do so. So at this point, I am done. Okay? On to problem 3. Problem 3, they look very similar. I want to look and see is there any way I can simplify them to start with, and there is not for the x minus 4. The x minus 4, I do not have a GCF. How do I know that? There's no number in front of the x, there's no letter behind the 4, and then my denominator, I have a little bit of an issue here. I do not like my x's to be negative. And right now, my x is negative. What I'm going to do is I'm going to rearrange this. And then I want to look at this. How can I change my x from a negative to a positive? Well, the only way I can do that is to divide by -1. But I'm not really going to divide. I'm going to take out a greatest common factor. This has a -1 in front of it. 4 is divisible by 1. So I'm going to take out a -1 and make this positive x minus 4. What that does for me is it allows me now to go ahead and cancel out my x minus 4's, leaving me with 1 over -1, which is just -1. On to example 4. Again, I have an issue with my denominator, but we won't talk about that yet. I'm going to go ahead and simplify my numerator as far as I possibly can, and then I'll worry about my denominator. So I have 5x minus 15. I have two terms, meaning I'm either looking for a GCF or I'm looking for the difference of two squares. In this case, x is not squared, 5 is not a perfect square. I know for a fact I do not have the difference of two squares. So I'm going to look for a number or a combination of numbers and letters that 5x and 15 are both divisible by. Well, 5x and 15 are both divisible by 5, meaning I'm left with 5x divided by 5 is x, -15 divided by 5 is -3. All over. What's my issue with 9 minus x squared? Again, my x is negative, and I don't like that. So I'm going to rearrange this to have it be negative x squared plus 9. And just like I did on the last problem, what I can do at this point is I can take out a GCF of -1, which would allow me to make my x squared positive and my 9 negative. Now, on every step of these problems, I want to double check to make sure that things cannot be simplified. So I'm going to look at my numerator. 5 times x minus 3 is going to go ahead and stay. The reason why it stays is if I were to distribute that, it would take it back to the way it started. I don't want to do that. Okay. In the denominator, I have -1 times x squared minus 9. Well, x squared minus 9 is two terms. So it's either going to be a GCF or the difference of two squares. Well, looking at x squared minus 9, x squared is a perfect square, 9 is a perfect square, and it is subtraction. So I can go ahead and factor x squared minus 9. It will give me 5 times x minus 3 over -1 times x plus 3 x minus 3. And if you're not quite sure how to factor the difference of two squares, remember that we did do it right up here in example 4. Okay. At this point, I'm going to look for things that I can cancel. I can cancel the x minus 3's out, and I can look at this 5 divided by -1 to go ahead and simplify that. Well, 5 divided by -1 is -5 over what's left in my denominator, x plus 3. All right. Moving on to example 5. My numerator is 2x minus 12. 2x minus 12 is not the difference of two squares. Therefore, I'm looking for a greatest common factor. There is a number in front. I should have a greatest common factor here. What are 2x and 12 both divisible by? Well, that number is 2. 2x divided by 2 is x. Negative 12 divided by 2 is negative 6. All over. What am I going to have to do with x squared minus 7x plus 6? In this case, it has 3 terms. When I have 3 terms, my only real option is generic factoring. So I need to make a factor tree. The middle term is negative, meaning the larger numbers are negative. I need to multiply to a positive, meaning the smaller numbers are positive. Now, which group is going to add to negative 7x? It'd be negative 1 and negative 6. So I can factor into negative 1 and negative 6. If you do not remember how to factor, we just did a review of that on example 3 up in the review section. Okay. So both my numerator and denominator are simplified as far as they can go individually. What I'm going to look to do now is go ahead and simplify them together. So the x minus 6's will cancel. I'm left with 2 over x minus 1. And that is that problem. On to 6. What I'm looking for in 6 is, again, to simplify the numerator by itself, then the denominator by itself, then try to simplify them together. So I have 3x plus 12. Again, that's only 2 terms. It is definitely not the difference of 2 squares. I don't have subtraction. So what are 3x and 12 both divisible by? That number would be 3. 3x divided by 3 is x. 12 divided by 3 is 4. Over. What can I do with x squared minus x minus 20? Again, 3 terms, so I can make a factor tree. 1 times 20, 2 times 10, 4 times 5. Okay. Middle term's negative, meaning the larger numbers need to be negative. Need to multiply to a negative, meaning the smaller numbers need to be positive. Which group will add to negative 1, which is my middle term? That would be x plus 4, x minus 5. Okay. What you can start to notice every once in a while is you might be able to use the idea of the numerator to see if my denominator will break into that. It is context clues. It doesn't always work, but it is a good way to check and see if you're stuck, give you an idea of what to try to start with. Okay. At this point, both the numerator and denominator are simplified, so I'm going to simplify between them, cancel out the x plus 4's. So I have 3 over x minus 5. My computer's messing up here. Hold on 1 second. Bear with me. So I have 3 over x minus 5 as my answer. All right, moving on. 7, I have to generically factor both the numerator and denominator. So factor trees for both. 1 times 6, 2 times 3, 1 times 6, 2 times 3. In the numerator, my middle term's negative, so the larger numbers need to be negative. They need to multiply to a positive or negative, so the smaller terms need to be positive. At this point, what would add to negative 1? Well, it would be x plus, or the positive 2 and negative 3. So my numerator is going to turn into x plus 2 and x minus 3. What I'm looking for now is for the denominator to either give me an x plus 2 or an x minus 3. So let's go ahead and factor our denominator. We've already made our factor tree. The middle term is positive, meaning my larger numbers need to be positive. They need to multiply to a positive, meaning my smaller numbers need to be positive. What will add to positive 5x will be positive 2 and positive 3. Now that I'm fully factored, I can go ahead and cancel some things out. Well, the x plus 2's can cancel out. I'm left with x minus 3 over x plus 3. Again, I can't cancel the x's or the 3's because they have to be identical in order for me to cancel. 8 has the issue that we had on the front where I need to rearrange. So I'm going to go ahead and rearrange the negative 4x plus 8 over. For my denominator, I need to make a factor tree. 1 times 8, 2 times 4. Middle term's positive. needs to multiply to a negative, which tells me that negative 2 and positive 4 is what I'm going to factor into. Now, looking at my numerator, I'm not done with that yet. I have a negative 4x and an 8. Negative 4x and 8 are both divisible by the same thing. It is the number 4. However, I want my x to be positive. So when I actually take out the GCF, I'm going to take out a negative 4. So negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. All over x minus 2, x plus 4. At this point, now that I'm fully factored, I can cancel in between, which leaves me with negative 4 over x plus 4. On to 9. 9 has x squared minus 64. Again, if you only have two terms, you're either looking for a GCF for the difference of two squares. In this case, it is the difference of two squares, so I'll make two sets of parentheses. In the first part of the parenthesis, it will be the square root of x squared, which is just x. Second part will be the square root of 64, which is 8. For the 8s to multiply to a negative 64, you need a positive and a negative. Again, if you're not sure about the difference of two squares, go back and look at the review example number 4, or you need to come in and see me. For the denominator, I have 2x and 16, which means I'm going to take out a GCF. The GCF would be 2, so 2x divided by 2 is x, 16 divided by 2 is 8. Again, context clues could have told me that that was coming. Now I can go ahead and cancel the x plus 8s. So I'm left with x minus 8 over 2. On to 10, I have an issue with the 6 minus x. So what I want to do is go ahead and rearrange that. My denominator is the difference of two squares, so I'm going to end up with x plus 6, x minus 6. For my numerator, I want to make sure my x is positive, so I'm going to take out a GCF of negative 1, turning my x positive and my 6 negative. My denominator is going to stay the same for a second. At this point, I can go ahead and start canceling. So I have the x plus 6's go away, or x minus 6's go away. Negative 1 over x plus 6 is my answer. On to 11. Sometimes we can have a GCF and a difference of two squares, and that's what we have just fallen into here. Okay, let's go ahead and look at our numerator. I have 2x squared minus 2, which means I have a GCF of 2, leaving me with x squared minus 1 over. I want to rearrange my denominator, so negative 3x squared plus 3. That's good so far. What can I do with the x squared minus 1? Well, I can factor that. That is the difference of two squares. So I can make this 2 times x plus 1, x minus 1. Over. What can I do with my denominator? Take out a GCF of negative 3, which turns my negative 3x squared divided by negative 3 just turns to x squared, makes my x positive. Positive 3 divided by negative 3 is negative 1. Now, if you saw that coming, what you could have done is kept the x squared minus 1 in your numerator, just x squared minus 1, because then you could have canceled the whole thing. But if you did not see that, what do I need to do next? 2 times x plus 1, x minus 1, over negative 3, x plus 1, x minus 1. What all is going to cancel out? The x plus 1s, the x minus 1s. I'm left with negative 2 over 3. That negative originally was in the denominator. You can leave it there, you can move it to the numerator, you can put it out front. It doesn't really matter. Okay? On to 12. 3x minus 27 has a GCF of 3, leaving me with x minus 9. In my denominator, I have the issue of having to rearrange again. So I have negative x squared plus 81. I want to take out a GCF down there. So my numerator stayed the same. I'm fully factored. Take out a negative 1, leaves me with x squared minus 81. Now, x squared minus 81 is the difference of two squares. So I can go ahead and factor x squared minus 81 to get me x plus 9, x minus 9. What cancels? Well, my x minus 9s will cancel, leaving me with 3 divided by negative 1 is negative 3 over x plus 9. And I am finished. So the most important thing about this lesson, the most important idea is you want to factor the numerator as far as you can, the denominator as far as you can. And then once I have everything fully factored, I'm going to look to try to cancel things from the numerator and the denominator that are 100% identical. Remember that if there's an addition or subtraction, they are stuck together. They are one piece. And the only way to cancel them is if that whole piece is in the numerator and also in the denominator. If you have any questions over this lesson, please make sure you bring them to me. Otherwise, thank you very much for watching the video and have a great day.